Hi there, IB. Today we're looking at natural logarithms. That's where we're using e as our base. So remember that number e, 2.718281, etc., is a number that appears a lot in nature and in finance. And so we refer it to, when we talk about these logarithms, we talk about the natural logarithm. So if we want to turn it into a log, remember it's the inverse function of our exponential function. So if this is our exponential function, y equals e to the x, then to get our inverse, do you remember? That's right, swap your x and your y. So x is equal to e to the y. So turn that into a log. So e comes down as the base of our log of x. And we get the exponent. So y is our exponent, x is our argument, or the number we're trying to find, b is our base. And because we use it so often, we give it a special way of writing. Instead of going log e, we use the terminology ln. So log, I don't know whether it comes from a French background of logarithm naturel or something, but ln for the natural log of x is equal to y. So that notation, I do the curly L, just so it doesn't look like 1n or something, but there's no harm with you just writing ln of x equal to y. So remember what our graphs look like? If we have y equals 10 to the x, it passes through 1. Hope you remember that. So that's our y equals 10 to the x. Then our natural exponent, e to the x, which is 2.71, will that be as steep? Not if the base is less than 10. So this won't be as steep as our 10 to the x. Still passes through 1 that comes in above on the negative values of x. And remember, to get our inverse, then we can draw in a line. I'm not going to scale this because it's too hard. If this is our y equals x line, then we can do a reflection. So they're all going to pass through 1. So this is 1. This will be 1 down here. So instead of the y-intercept being 1, the x-intercept is going to be 1. Now to test my artwork, this is 10 to the x. Well, I'll try again. We'll come down through there to be an asymptote to the y-axis. Make sure you don't touch it down there. And then for our, so that's our y equals log of x. So our y equal natural log of x is going to be in between here. So it's going to come down here, cross through at 1, and come to the right of that. So y equals ln of x. And this is y equals e to the x. So hopefully those graphs should look familiar to you. Different asymptotes, obviously, for our log functions. The only number that can be in our argument, the x has to be greater than 0, and the range for that is all real values, all real numbers. So let's go back to some of the basics again. Remember, if we want to write a number, 10 to the x is 30, then what sort of number will x be? What exponent do we need on 10 to give us 30? Because we know that 30 is between 10 and 100, the exponent's got to be some sort of number that's between 2 and 1. Because it's between 10, 10 to the 1 is 10, 10 squared is 100. So if you do that in your calculator, you come out with 1.477. So log of 30 is 1.47. So that means I can write 10 to the 1.477 is equal to 30. All right? Another way of writing that, to see different ways of writing it, with the gap here. Another way of doing that is 10 to the log of 30 equals 30. So as long as our bases match, this is a base 10, then this is the number we're looking at. Same story with e to the x of 30. So then you've got to think, well, what could x be between? Remember, e is about 3, 2.7. So 3 squared is 9, 3 9s are 27. So maybe we've got a number that's bigger than 3. So we're guessing here, x could be bigger than 3. What's 3 to the 4th? 3 27s are 81. So we're probably thinking to go to a number somewhere between 3 and 4. So I want to have an appreciation of what exponents give what. So in your calculators, find out what is ln of 30. So find that on your calculator, and we get 3.4. So our guess was right, somewhere between 3 and 4. So that means I can write e to the 3.40. This is obviously 3 significant figures. Is equal to 30. Or I could have done e to the, to find that exponent, I put it in my calculator with e to the ln of 30. And that finds my exponent. So here, x is equal to 3.4. All right, so the rules for natural logs, just like we've done for logs base 10, the natural log of 1 is 0. So that means that goes back to our graph. When we have x equal to 1, and here our y value is 0. That was our x-intercept. If we want to think about that as a different way, if we use our log rule, that's the same as saying 1 is equal to, this is a base e, so that becomes our base. This is our exponent, so it's e to the 0. We know e to the 0 is 1. Anything to the 0 is 1. ln of e equals 1. So if this base e, is the same as here, then what's the exponent on there? It's 1. So that's a true statement as well. So e is equal to e to the 1. If we have ln of e to the x, again, this is a base e, this is a base e, so our exponent is the answer. If I put e to the ln of x, that's what we were doing up here, e to the ln of some number, we get that number. So that will be x. Oops. Delete that. There we go. So again, e to the ln of x is x. So they're your rules. Try for understanding, not just rote learning rules. So let's do some practice with these. These are some questions out of 4D1. In one of the expressions, we're asked to simplify ln of e times e to the a. Couple of ways of dealing with this. We'll do 2 methods. You can always pause it, have a go, and then come and check your answer. So we could put those together. That's like e to the 1. Let's shift that one over. There we go. Alright, so this is the same as having ln of e to the 1 times e to the a, which is the same as ln of e to the 1 plus a, because our bases are the same. This is base e, this is base e, it equals 1 plus a. Another way of doing it is, if you remember, we'll go into this more in D part 2, when we were doing the log base 10, if we had two things being multiplied, and that's the same as adding their logs. So that's ln of e plus ln of e to the a. So if they're multiplying inside, that's the same as adding exponents. So bases the same, being multiplied, add their exponents. Ln of e is 1. Here we've got the same base, e and base e, so that gives us plus a. So two different ways of solving that one. This next one is just using a calculator to make sure you know where to find that. So in your calculator, if you then put in ln of 60, so to get e to the x, e to the x is the same as we're doing e to the ln, oops, we want e to the ln of 60 to see what exponent do we need. So ln of 60, we get 4.09, so this is the same as e to the 4.09, where x is corrected 4 decimal places. All right, 0943. So can you read that? Let me try that last bit again. 943. All right. In E, this is E. In E, we've got 0.006 is equal to e to the x. All right. So we need to find e to the ln of 0.006. So put that into your calculator. ln of 0.006 equals e to the minus 5.11599. If we want 4 decimal places, we need to round to that 9. So that becomes 60. The 599 rounds up to 60. You need to put that extra 0 in to have your 4 decimal places. So just watch your rounding. 4 decimal places, we need that 60. All right. Okay, let's look at some other ones. Indeed, part 2 of those rules that I was just talking about. So if we've got ln of a plus ln of b, then that's the same as ln of a times b. ln of a minus b, that's going to be the same as, hope you thought about it, ln of a over b. And n times ln of a, that's the same as ln of a to the power of n. So those rules are just the same as we did earlier. So let's look at a couple of examples with this. We want to write this as a single logarithm. So we're doing j here. If we've got 2 plus ln of 4, 2's not written as a log, so we need to write that as a log. So 2 is the same. Remember that ln of e is 1, so we could write 2 as 2 ln of e plus ln of 4. Let's put the 2 inside the ln of e, so we get ln of e squared plus ln of 4. So now we can put them together as one log, we get ln of 4e squared. The next one, we want to write that the same in the form of ln of a, put the logs together. This one is simple because it's similar to that last one. Put the 5 inside, so it becomes 3 to the 5th plus ln of 4. So we get ln of 3 to the 5th times 4. We need to put that together. So 3 to the 5th, we've got 243 times 4. So we end up with ln of 972. So keep your calculator handy with all of this. These next ones, we're going to show that. Remember, you can't use the answer. So if we want to show that ln of 500 is the same as these things, when I look at that question, if I see minus ln of 2, then I'm going to think, if I put that together as logs, that's the same as the log of something or other over 2. And if I've got 500 at the front, what could be, how do I get 500 by something divided by 2? Then that must be 1,000. So my method for solving this is to go ln of 500. I start with the left-hand side. I need to make sure I end up with the right-hand side. So that's the same as ln of 1,000 over 2. So I can now split that into ln of 1,000 minus ln of 2. I then start that into my calculator. So ln of 1,000. And when you check that, you come up with, geez, surprise, surprise, 6.907, rounding it to 4 decimal places to come out with that answer. So we've shown that. In the next ones here, we've got to write these without logs and assume that all terms are positive, because we can't take the log of a negative number. So in our first one, we want to be able to get this without any logs. So if we've got ln of d equals ln of x plus 1, when you write that, make sure your plus 1 is separate. If you want to do ln of x plus 1, put it in brackets. All right, so let's put the logs together on one side and leave our numbers separate. So let's subtract ln of x, that equals 1. If we're subtracting a log, that's the same as dividing the arguments. That equals 1. Now let's use our log rule. So therefore, d over x equals e to the 1. In other words, d over x equals e. In this next one here, that will be similar. ln of f equals minus ln p plus 2. So we have ln of f plus ln of p equals 2. ln of f times p equals 2. Use your log rule. E, your base, comes over here, and that becomes your exponent. So fp equals e squared. And that's it. Anyway, I hope that makes sense and that you can work through this. You can be ready with any other questions you might have in class. Thanks for listening and have a good evening.